In this video we will demonstrate the operation of diagnostic devices for the windings of electrical machines. Indicator EDO06 is designed to control three-phase windings. It checks the winding for inter-turn short circuits without dismantling and disassembling the machine. The indicator is necessary for operational control, incoming control, for example, if a used engine is purchased, for acceptance after repair, for commissioning after long-term storage, and for final control, if you repair electric motors. When searching for short circuit turns, the device compares the currents of the two phases of the winding when an alternating voltage is applied to them with an amplitude of up to 10 volts and a frequency of up to 10 kHz. We connect the connecting cable to the phases of the winding of a working motor. We turn on the device. At the same time, it shows the integrity of the circuits of all phases of the winding. If any phase is disconnected, a dash will appear on the display instead of its letter designation. In this case, the device shows phase B failure. By pressing the Enter button, we connect the winding phases to the device in pairs. With that, the unbalance factor of the phase currents appears on the display each time. As we can see, all the values on the display are less than 10, and the green LED is on. This means that the winding is in good order. Let's check another engine. In this case, we see that the allowed unbalance factor is exceeded, meaning it is higher than 10, and the red LED is on. But we cannot yet be sure if there is a defect, because the unevenness of the air gap and rotor defects affect the value of the asymmetry coefficient. To eliminate these factors, we slowly turn the rotor, and try to achieve the minimum value of the unbalance coefficient in all three pairs of phases. In our case, it can be seen that for each pair of phases, the unbalance factor is within an allowed range and the green LED lights up. This means that the stator winding is in good order. If the green LED does not light up when the rotor is turning, then there is a defect in the stator winding. The EDO06 device also checks the state of the frame insulation. We connect the connecting wires to one of the windings and to the motor casing, apply a constant voltage, 1000 volts, and see the insulation resistance value in megohms on the display. If this value exceeds half of a megohm, the green LED is on. If it is less, the red LED is on. Indicator EDO07 performs all the functions of EDO06. In addition, with the help of an induction sensor, it detects the grooves in which the coils with short circuit turns are located. Thanks to this function, EDO07 can be used to diagnose not only three-phase windings, but also any other windings laid in slots. Positioning the induction sensor along the axis of the groove and pressing it tightly to the surface of the core, we pass through all the grooves one by one. If a coil with a short circuit turn is detected, the device gives light and sound signals. Indicator IDVI05 is the most multifunctional of all winding diagnostic devices. It performs the same functions as the EDO07 device, and also checks turn-to-turn insulation of low-voltage machines for wear, pole coils for the presence of turn-to-turn short circuits, short-circuit rotors for the presence of rod breaks. Unlike EDO devices, when checking a three-phase winding for the presence of turn-to-turn closures, a pulse voltage with an amplitude of up to 1000 volts is alternately applied to its phases. We connect the connecting cable to the phases of the winding of a working motor. Turn on the device. It shows the integrity of the circuits of all phases of the winding, the same as the EDO indicators. By pressing the Enter, we connect the first pair of winding phases to the device and obtain an approximate value of the difference coefficient of the test voltage pulses at a voltage of 340 volts. Then we press the Enter twice more and we get the exact value, at a voltage of 340 volts and 1000 V. Then the next pair of phases. And finally, the last one. In our case, we see zeros on the display. The green LED is on during all measurements, which indicates the ideal state of the stator winding. Let's take another engine. We can see that the approximate value of the difference coefficient is different from 0. This may be due to uneven air gap and rotor defects. Turning the shaft slowly, we try to achieve the minimum value of the difference coefficient. Next, we get the exact value at a voltage of 340 volts and 1000 volts. We see that when a voltage of 1000 volts is applied, the difference coefficient exceeds the allowed value and the yellow LED is on. This suggests that there are no turn-to-turn short circuits in the stator of the machine, but the turn-to-turn insulation is worn out. Let's check the same engine after closing several turns of the windings. Here we see an unacceptable value of the difference coefficient at a voltage of 340 volts, and the LED glows red. In this case, the voltage of 1000 volts is not applied and the device proceeds to test the next pair of phases. Based on the results of the check, we conclude that there are inter-turn short circuits in the stator winding. Let's check the short-circuit rotor for broken rods. We link a connecting cable with two clamps to the device and connect it to one of the phases of the stator winding. We turn on the device, press the enter. Slowly, at a speed of about 1 rpm, turn the rotor for one full rotation. After that, press enter and see the value of the maximum difference factor of the test voltage pulses on the display. In our case, it is equal to 0 and the green LED is on, which indicates that there are no defects in the rotor winding. Let's check another engine. Please note, if it is not possible to connect the cable to one phase of the motor, it can be connected to the beginning of two phases, and the readings on the display must be multiplied by 2. If the received value is less than 10, there are no defects. In this case, the maximum difference coefficient exceeds the allowed value, while the red LED is on. This means that there is a defect in the rotor winding. And finally, let's check the pole coils of a DC machine for the presence of turn-to-turn closures using the example of the main poles of a 4-pole machine. We link the connecting cable with two clamps to the first tested coil, then turn on the device. Press and hold the enter button for at least 2 seconds. The display shows the number of poles. Currently there are 2. In our case, there should be 4 poles, so we press enter and set 4 instead. Press and hold the enter button. The display shows the designation of the first tested coil A. Press enter. Test voltage pulses are applied to the coil and flashing symbols appear on the screen. When the B reading appears, the cable can be connected to the next coil and so on until the end reading appears. After that, alternately pressing enter, we monitor the value of the pulse difference coefficient for all coils. In our case, the coefficient exceeds the allowed value for coil A. This means that it has short circuit turns. Indicator IDVI04 is intended mainly for those who working in the field of repairs of electric motors. It detects short circuit turns in the winding only of a disassembled motor. Just like IDVI05, it checks the coils of the windings laid in the slots and the pole coils for the presence of turn-to-turn closures and the state of the frame insulation. In addition, it can detect mechanical damage to the turn-to-turn insulation of the winding laid in the grooves. The device is equipped with 2 induction sensors, one large and one small. The small induction is useful for testing small pitch stators. Unlike the EDO07 and IDVI05 devices, different test voltages can be applied to the sensors. The small sensor is supplied with voltage with an amplitude of 1, 2, or 4 volts/turn. For a large sensor it is 4, 8, or 16 volts/turn. We select the required test voltage on the display of the device, place the induction sensor along the axis of the groove and press it tightly against the surface of the core. After that, we pass through all the grooves one by one. If a coil with a short circuit loop is detected, the device gives light and sound signals. You can find more information on our website, the link is in the description. Thank you for your attention.